Start lecture number 8 of MT 330 Applied Probability and Statistics. In previous lectures or lecture number 7 or different lectures, we discuss binomial distribution, all discrete types of probability distribution, and as well as we started in last lecture number 7 some continuous probability distribution, PDF, CDF, cumulative distribution function, and by help of PDF and CDF we can find probabilities of several events. After that we started the continuous probability distribution, which is the uniform probability distribution, and uh, by help of uniform distribution we solve different types of numerical follows, different types of problem follows uniform probability distribution. Now student, one of the most important type of probability distribution, which is said to be the normal probability distribution, one of the most important type of continuous probability distribution. This is the probability distribution in which the all probability, where the all probability distribution, for example binomial distribution, in the binomial distribution the numerical follows the binomial distribution, but in some circumstances or some reason we do not solve by help of binomial distribution, so we can approximate binomial distribution into the normal probability distribution and then we can solve easily. So normal distribution is actually the approximation form of all probability distribution. Where all probability distribution becomes restricted, then we follows normal probability distribution. So we are going to start one of the most important probability distribution in our syllabus, normal probability distribution. This is the what you can say, some of the introduction of normal probability distribution. In normal probability distribution, continuous probability distribution is called the normal curve, represented by the next, for example, slides, and used for physical measurements, different meteorological department, rainfall studies, for example, normally distributed or not. History is that student, De Moivre's, for example, De Moivre's scientist, one of the most important scientists in mathematician actually. 1733, De Moivre's derived the mathematical equation of normal curve, for example, and also Gaussian distribution in for example, engineers and scientists said to be the Gaussian distribution, because Gauss is the engineer derived the parameter of this normal probability distribution. So another mathematician, Gauss, is defined the parameter, derived the equation of studies of the errors of normal probability distribution. So that's why it is also said to be the Gaussian probability distribution. So in for example, engineers and scientists, because Gauss is an engineer, was an engineer, for example. So because Gauss was an engineer, so in engineers and scientists, for example, engineers, engineering field, and scientists, for example, is said to be, engineers and scientists is said to be Gaussian distribution. Gaussian distribution. So engineers and scientists is said to be the Gaussian distribution, and in journal is said to be the normal probability distribution, because Gauss is one of the engineer, also mathematician, derived the equation of normal distribution. That's why in worldwide, engineers and scientists, you also are engineers and scientists, is said to be Gaussian distribution. So this is a different name, but it is the same theory, normal distribution. Some people say that Gaussian distribution, and some people also say that, for example, or Laplacian distribution. Laplacian distribution, because French mathematician Laplace is also derived the parameter or defined different parameters. So that's why we said to be the Laplacian probability distribution. So these are three names of normal probability distribution. In journal, worldwide, internally, we can say that normal probability distribution. In France or European countries, for example, said to be the Laplacian probability distribution, and engineers and scientists mostly said to be the Gaussian probability distribution. So this is somehow the history of normal probability distribution. Now student, this is the normal probability distribution PDF and the graph of normal distribution. A continuous random variable having bell shape. One of the first properties said to be the bell shape distribution. In the following figure is said to be a normal random variable. A mathematical equation is depends upon two parameters, said to be two parameter. If anybody says that, for example, this random variable follows normal distribution, then he must define two parameter. What is mean mu? This is mean mu. This is said to be the mean. And what is the standard deviation sigma? So there are two parameters of normal distribution, with what mean, with what variance, with mean mu and with standard deviation sigma, for example. So this is what we have, the graph of normal probability distribution, simply symmetrical bell shaped curve, just like that. For example, student, symmetrical bell shaped curve, for example. So this is the particular graph of normal probability distribution, symmetrical and bell shaped curve, just like that, and in central point, this is a perpendicular central point, it is lie the value of mu mean always lie in the center point. So the right tail area from this mu and the left tail area from this point is said to be equal 50-50%. That's why it's said to be the bell shaped distribution. This is these are named bell shape, for example, or symmetrical. These are two names of this normal probability distribution. Symmetrical stand symmetrical about bell shape, or symmetrical about mu mean. So student, there are two parameters in normal probability distribution. Mean mu is said to be the mu mean, and sigma is said to be the, as usual, standard deviation. If we are going to take a square, then it becomes variance. So this is what we call normal probability distribution having bell shaped curve graph with mean mu about symmetrical graph about mean mu. So this is what we have, normal probability distribution sketch or shape, bell shape or symmetrical distribution. Okay, now this is the PDF formula of normal probability distribution. Students, I say earlier, if anybody says that this random variable x follows normal distribution, then it must define. So this is the density function of normal probability distribution with mean mu and variance sigma square. F of x equal to 1 upon sigma under root 2 pi e to the power minus half x minus mu upon sigma whole square, having two parameter with mean mu and with standard deviation sigma. And here x lie between minus infinity to plus infinity, and mu also lie between minus infinity to plus infinity, and sigma standard deviation always greater than 0, positive as usual. So we can write, student, as the above density function as x follows n normal distribution with mean mu and with variance sigma square, for example. So this is the standardized method. If we are not going to be write this PDF or not learn this PDF, very difficult, for example, so we can write as this one as x follows normal with mean mu and with variance sigma square, for example. So the density function of normal distribution depends upon two parameters, with what mean, with what variance, and we can write as x follows normal distribution with mean mu and with variance sigma square, for example. So student, if we have, for example, x follows normal distribution, just like that, for example, x follows normal distribution, I write here, if x follows normal distribution with 1, 4. So what is the value of mu, student? What is the value of mu? This is x coordinate, this is y coordinate. The x coordinate is said to be the mu and y coordinate is said to be the sigma square. So mu is equal to 1 and sigma square is equal to 4. You can take a square root, then sigma becomes equal to 2. So putting values in this PDF, you make a PDF without any problem. So putting this, how we can find PDF? F of x is equal to 1 upon sigma, that is 2 dot under root 2 pi. We make this PDF, this random variable PDF, where mu is equal to 1 and sigma square equal to 4. So find the value of mu and sigma square and put the values in the PDF formula. You may got this random variable PDF as well, e to the power minus half x minus mu is equal to 1 upon sigma 2 whole square. This is what we have, normal distribution PDF. You make very easily. So this is, student, this is the short notation. This is the short notation of normal distribution. X follows normal with mu comma sigma square. If anybody says that X follows normal with 1 comma 4, that is mu equal to 1 and sigma square equal to 4. So putting the values, you make a density function just like that, where x lie between as usual minus infinity to plus infinity, minus infinity, sorry, this is lower limit, minus infinity to plus infinity. So this is what we have, normal probability density function. Now some of the characteristics of normal distribution already we discussed. One of the characteristics, bell shaped single peak, already we discuss, only we have is it has single peak distribution. Now second property, see that, student, arithmetic mean, median and mode are always equal to each other. In normal distribution, mean, median, mode are always lie in the central point. This is the central point. See this one, this is what we call mean, or we can say that in same point lie median, and in same point mode also in this same point, for example cut point. So this is what we call mean, median, mode. Mean, median, mode are always equal to each other in normal probability distribution, which always lie in the central point, for example. So mean, median, mode are always equal to each other. The total area under the curve normal distribution, because it is a PDF, must be equal to 1, and half area lie towards the for example right side of the center point, and half area lie lower, for example left side to the center point. See this one, again we make a graph of normal distribution. This is what we have, mu, mean, median, mode, all three measurement of central tendency are equal in this point, and right tail area and left tail area from this central point mu always equal to each other, 50% for example, and this is also belongs to 50%. So this is the property number, for example characteristics number 3. It is symmetrical about mean. Symmetrical about mean, it is always symmetrical graph, equal areas between them. Okay, now student, next property is the not closer to the x-axis. It is a very closer to x. These are tails, these are right tail and left tail, closer to x-axis but not touches the x-axis. See this one, for example if we are going to extend this tail, right tail, then these parallel to x-axis, for example parallel to x-axis, not touches the x-axis, they are not going to touch the x-axis. So this is what we call extend indefinitely. For example if you extend undefined or unlimited points, then also these right tail and left tail do not touches the x-axis. Remember all these things. So the location of normal distribution, mu location, for example is, this is the location point, show mu, and the spread is show the standard deviation. How many spread are there? This is a spread point, this is the variation it is said to be. So this is what we call spread point, spread or variation. So spread depends upon sigma, standard deviation of the normal distribution, and the location depends upon the mean. This is the mean of, this is what we call location, how we locate from the center point or origin point from the normal probability distribution. So this is what we call the characteristics of normal probability distribution. See this one, simple graph of normal distribution, student. This is what we call right tail, this is what we call left tail, this is the center point where mean, median, mode are always equal to each other, where and it is equal to, in generally it is equal to the mu, for example the notation, and the theoretically right tail, and this is theoretically said to be the left tail. You can extend from minus infinity to plus infinity. So that's why x lie between, for example in here x lie between, in normal distribution PDF lie between minus infinity to plus infinity, because we can extend this graph, for example this one, we can extend this graph, for example this one. So we can extend but do not touch the x-axis. These asymptotic points or tails, right tails and left tails, do not touches the x-axis, parallel to x-axis from minus infinity to plus infinity. So this is what we have idea about normal probability distribution sketch. Now if normal, there are two different points of normal probability distribution. If mean mu are different, see this one in the next graph. If mean mu are different from one or more normal distribution, for example in this way mean equal to 283, in this graph mean equal to 301, in this graph mean equal to 321. So means are different in the normal probability distribution, but the standard deviation or variances are same. So student, the location must be changed. This is the graph, make another location, this is the normal distribution, make another location, but the height remains the same. See this one, the height. If sigma standard deviation becomes same, then the height of all normal random variable becomes same. So this is the another property of normal. If we have more than two or more than two random variable, follows normal probability distribution. For example, in this one black, in for example in red color, I already plot, for example in red color, for example this graph here, for example x follows normal distribution with what mean 321, and with what standard deviation, or maybe said to be the variance 1.6. This is what we have, standard deviation 1.6. So in red color graph, for example mean this and standard deviation this. For example in black color graph, this is the black color, for example graph this one. In this color, for example y follows another, take another random variable, also normal distribution, but mean becomes changed 301 comma, standard deviation becomes remains same 1.6 is the standard deviation. So this is also follows normal random variable, but the height remains the same. See this one, because the standard deviation remains the same. And if we are going to take this one green color graph, for example, so in this way we are going to take, for example consider green color, or if we have show this one just like that, another random variable t is another random variable, for example follows normal distribution with what mean, with 283 is the mean, and standard deviation remains same, which is equal to 1.6. this is the standard deviation. So in three graphs, see this one, see the difference between them. If the standard deviation becomes same, two or more normal random variable, then the height remains the same. This is the actually theory says that if the standard deviation becomes same, the height remains the same. But you see this one, if the standard deviation becomes different, see blue one graph, see this is the green one, this is the red one. In this graph this mean also becomes different. If mean become different, then we can change the origin. This one, the origin of the first blue graph, this is the origin of the second green color graph, all follows normal distribution, and this is the follows red color graph, for example. But if we have different standard deviation, see this one, in blue color graph standard deviation 41, in green color graph standard deviation 52, and in red color graph standard deviation 20. All these standard deviation are different. So how we can perform standard, if standard deviation are different, then how we can find height of normal distribution? So listen very carefully students, the more standard deviation, what is the where the more standard deviation all of between all of three, the more standard deviation, the more standard deviation having lower peak, having lower peak, having lower peak, and the smallest standard deviation having larger peak. So this one, this 52 psi, this is the standard deviation of all, this is the largest standard deviation among all of these three. This is the largest standard deviation, but the height of graph becomes smaller. See this one, if you can take any height but a smaller height, for example. And if we have smallest standard deviation amongst all three, this is the smallest standard deviation, this is the smallest standard deviation, so we can take more height amongst all three. See this one. And for example this is the standard deviation 41, because this 41 is smallest than the 52, so the height of blue graph must be larger than the green graph. So this is all about, this is what about say that if the standard deviation becomes changed, the height remains the change, and the inversely proportional, the larger standard deviation having lowest height, and the smallest standard deviation having the largest height. Okay, so this is what we call normal probability distribution, and if we have more than two normal probability distribution, then we can compare the graph very easily. The standard deviation becomes the same, the height remains the same, but the standard deviation becomes different, the height becomes the different, and the smallest standard deviation make more height, smallest standard deviation confirm more height, make more height of normal, this normal probability distribution. So this is what we have called graphical shapes of normal probability distribution. Now by help of students, by help of normal distribution, this is what we have distribution, or for example shape of normal distribution. By help of this formula we cannot find probabilities by help of normal distribution, because the CDF of this normal distribution density function do not exist. We cannot find the CDF of this formula, and by help of this formula we cannot find probability, for example x greater than something, or for example x we are going to find, if we are going to find probability for example x greater than 5, then how we can find integral 5 to infinity 1 upon sigma under root 2 pi, for example e to the power minus half. So this is very difficult integration, students. So we cannot find probabilities by using this normal density function. We cannot find this probability or any type or any function or any type of this probability by help of this normal probability distribution. So how we can find probability by using normal distribution? There is a special case, students. There is a special case in which we are going to find the probability by help of normal probability distribution. So let's try to obtain the special case of this normal probability distribution and obtain the special case of normal probability. Where is the special case of this normal probability distribution? This is, student, what we call standard normal probability distribution. This is the special case of normal probability distribution. How we can define? See this one. In a normal probability distribution, if mean mu becomes equal to 0, see this one very careful. If mean mu becomes equal to 0, mean mu becomes equal to 0 in normal distribution, already discussed in the previous slide, and the standard deviation becomes equal to 1, and standard deviation sigma becomes equal to 1, mean mu becomes equal to 0 and standard deviation sigma becomes equal to 1, then the normal distribution follows a standard normal distribution Z. This is what we call Z distribution, or we can say that standard normal probability distribution. Standard normal probability distribution we can write as standard normal probability distribution. Okay, so this is what we call standard normal probability distribution Z, and Z is the specified English alphabet, is said to be the standardized random variable. Where in normal random variable, see this one in the previous slide, for example in normal random variable, this is x follows normal distribution, this is y. For we can use any alphabet, any variable notation, x, y, t, but standard normal distribution we only use Z. Z is the fixed random variable or fixed alphabet especially used for standard normal probability distribution Z. We can say that the Z is the Z value assigned between the values by help of table. Z table also available, which is said to be the standard normal distribution, and by help of Z table, students, by help of Z table we can obtain probability. We can obtain probability. So this is the what we call standard normal distribution. I repeat once again, in normal distribution, if mean mu becomes equal to 0 and sigma standard deviation becomes equal to 1, then the normal distribution follows standard normal distribution Z, and we can write as, student, we can write as Z follows normal standard normal distribution with 0 comma 1. Simple notation already we discussed in the previous slide of normal distribution. See this one, short notation. We discussed the short notation of PDF density function. We can write as x follows normal with mu comma sigma square, before comma x coordinate, for example, it can be represented by mu, and after that, for example, this is the y coordinate, it can be represented by sigma square. So this is x, y, any random variable are there, but if we write z, then this will becomes 0 and this will becomes 1. See this one, this mean becomes 0 and variance or sigma standard deviation becomes equal to 1. So we write not x, not y, z. Z is the special case of standard normal probability distribution. If mean mu becomes 0 and standard deviation, if we are going to convert mean equal to 0 and standard deviation 1, then we can write z follows normal distribution with mean mu 0 and with standard deviation or sigma square equal to 1. So this is what we call standardized random variable, and we have z, where z, how we can convert mean 0 and variance 1, sigma 1, for example, because this is the transformation, most important transformation in our, for example, this lecture. This is student transformation in which we are going to convert x into the z, normal random variable, into the standardized normal random variable z. If x, y, any normal random variable becomes converted into the z, then this is follows normal distribution with mean 0 and variance 1. This is automatically, we can say that mean 0, mean becomes 0 and the standard deviation becomes 1. So this is what we had, z equal to transformation x minus mu upon sigma. We are going to subtract random variable from random variable mu, x minus mu, and divide by standard deviation. For example, if we have see this one, for example, if we are going to find probability x greater than 3, for example, then first we try to convert x into the z. How we can convert? Subtracting mu from x minus mu, and divide by sigma. See this one transformation. So subtracting mu from x and divide by sigma. Also in greater than, right hand side of greater than, 3 minus mu upon sigma. So in this way we are going to subtract, for example, x minus mu upon sigma greater than 3 minus mu upon sigma. This will becomes automatically z and greater than something. So this is what we call, student, standard normal probability distribution z. X minus mu upon sigma is the transformation in which we are going to convert x to the z. So this is a special case of normal distribution, student. By help of this we can find probabilities of several events. For example, this is the table in which we are going to find area under the curve of normal distribution. First of all, I explain the table, z table. This is area under the standard normal curve. Student, in column wise there is a value of z. This is the z value starting from minus 3.4 to, see this one in next page, plus 3.4. So student, in z table, or for example the nature of z table is simply that, for example, we have to obtain here, see this one, for example, mean 0. This is the standard normal graph z, because mean becomes 0. So this table, for example, lie from minus 3.4 to plus 3.4. So it is not necessary minus 3.4 to plus 3.4. We can apply this table minus 3.9 to plus 3.9, minus 4.0 to plus 4.0. So as much as many are negative values, as many are positive values are there. So this is what we have characteristics of normal probability z table. So these are table, for example, actually these table belongs to minus infinity to plus infinity. Students, see this one, this is the minus infinity and this is the plus infinity, for example, minus infinity to plus infinity. So this is the table in which we are going to study all as many negative values are there, as many positive value also there in the right hand side, so equally distributed between them. So this is what we call z table, for example, and we are going to find, and this is the CDF table. See this one, student, this is the CDF, standard normal CDF table. So we cannot find probability greater than something, we must convert 1 minus less than. So this is what we have, z value from the first column, and from for example this second, third column, these are characteristics, just like log table characteristics and Mantissa value 0.00, 0.01 point and point till 0.09. These all are probabilities, students. These are probabilities from 1 is 1.3, for example this, and plus 1.3, for example this. So these are probabilities of z tables. So this is what we have, z table. If we are going to convert z table, then we can find probability very easily. Now start the numerical and try to solve by help of normal probability distribution table. The weekly income for men in a glass industry, first for example numerical in the normal probability distribution, we have industry follows normal probability distribution. Student, the identification of normal distribution is very easily. There is a written in the word follows normal distribution with mean $1,000 and standard deviation $100. So this is what we have, mu equal to, first we try to make the data, mu equal to $1,000 for example, and standard deviation, see this one, standard deviation is the $100 for example. So in any numerical of normal distribution, the mean, mu and standard deviation must be given. So remember all these things, mean, mu and standard deviation must be given in the normal distribution. So what is the z value? What is the z value? For example, find the z value of 1,100 per week dollar for a foreman who earn this value. So how you can find z value? If you are going only find z value, this is the z value. So how you can find z value? This is a transformation, use transformation. See this one, for x equal to $1,100, for example this is the value of x. See this one, who earned this value, this is the value of x. So x minus mu upon sigma, write the formula of z transformation, put the value of x, put the value of mu, putting values of mu and sigma as well, this will becomes 1.0, this is the value of z. And now for a foreman who earn 900 per week dollar, $900 per week. So how you can find, this is the value of x for example. So x minus mu upon sigma, write the formula and putting the values, solve this one, you got minus 1.0. So this is the method in which you are going to convert, how you are going to convert z, how you are going to convert z, not probability. Now see this one, another example. For example, in this example we are going to find probabilities and probabilities of several events. See this one, students. In earlier example of similar example, consider with mean $1,000 and standard deviation $100. What is the likelihood of selecting? What is the likelihood of selecting between stand for? What is the probability? What is the probability of selecting? What is the probability of selecting for men whose weekly income between $1,000 to $1,100, for example? We are going to find, students, we are going to find between probability between $1,000 to $1,100, for example. This is the probability we are going to find. Likelihood means probability. Mu is equal to, student, where mu is equal to $1,000, make a data, sigma is equal to $100 similarly. Okay, now we have to find probability x lie between 100 to so first of all we have to convert into the z, students. First of all we have to convert into the z. How we can convert? $1,000 is the lower limit, we are going to find. I write once again 1,000, for example x lie between 1,000 to 100 and 1,000 or 1,100. Okay, so this is the probability. So student, make this x into the z. So see this one, you can make by this method, I already discussed in here, or you can make, for example, this method. In previous, for example, we discussed 1,000 x lower limit, separately make x equal to $1000 by putting x minus mu upon sigma, x minus mu upon sigma, this will become 0.00. And by putting the upper limit of this transformation, x minus mu 1100 minus mu is equal to 100 divided by sigma 100 is equal to this one. You can solve by by this method also directly. 1000 minus mu divided by sigma, or x minus mu divided by x minus mu divided by sigma. So in middle part you subtract minus mu and divide by sigma. In lower part also subtract mu divide by sigma. In upper part, upper limit, 1100 minus mu divided by sigma. So you make directly, not necessary is this one for example applied. So in middle part becomes equal to x minus mu upon sigma becomes equal to z, and in lower and upper part, lower limit and upper limit, put the values of mu and sigma and solve this one just like that. 1000, just like that, 1000 minus mu also becomes 1000 in given in the data, divided by sigma. What is sigma? 100. Now upper limit 1100 minus mu 1000 divided by sigma 100, and solve these two upper limit. You may got 0.00 and 1.00 respectively. So I write in the bottom, probability z lie between 0.00 and the upper limit becomes 1.00. Now solve this one by help of for example calculation. This one we have got probability 0.00 dash, upper limit is 1.00. Now how we can find these probabilities, students? In normal distribution, because the normal z distribution is the similar as conducted by PDF, CDF for example. So how could you find the probability? By help of CDF. This become lower limit and upper limit, intervals for example. So phi upper limit, phi is the notation, for example for example write in the above part, if standardized normal random variable z, if you are going to find probability z lie between a to b, students, for example just like intervals, then phi upper limit b minus phi lower limit a. Just calculate probability phi upper limit minus and then subtract phi of lower limit. Phi is the notation of table. This may you have to find table of standard normal distribution. This is also by help of table of normal distribution, standard normal probability distribution. So first of all, these interval write into the form of phi of upper limit minus phi of lower limit 0.00. Now by help of table you have to find this value. By help of again table you have to find this value. Now see this one, student, how you can use table. 1 plus 1.0 then 0. So go to the table of standard normal distribution z, and we are going to find probability. In this table phi 1 point, what is the probability of this upper limit, for example students? 1.0 and then characteristic 0. 1.0, first of all see 1.0 in the first column, and then 0 is the characteristic 0.0. for example on the 0, see this one table. How you can use table? By help of table you can find probability of normal distribution. So phi of 1.00. so see this one, make 1.00, see this one 1.00 1.0 plus 1.0 in the for example plus column of normal distribution. See this one plus 1.0 plus 1.0, this is plus 1.0. okay, now see plus 1.0 row, this is the row of this 1.0. how you can find this probability? See 1.0 and then 0 of characteristics, 0 this line 0, this is the 0, this is 1, 0.01 stand for 1, 0.02 stand for 2, 3, 4, 5 and similarly so on. So 1.0 then 0, 1.0 and then for example of 0 column, this is the 0 column, what is the value? 0.8413. So write 0.8413. This is the probability. If you are going to find, for example, if you are going to find phi 1.02, see this one. So make 1.0 in the first column, for example, this is 1.0, and then go to the 2 characteristic. 2 stand for 0.02. This one 0.8461, right, 0.8461. okay, this is the use of normal distribution table, for example. So 0.8413, right, in the values in the column 0.8413, this is the probability. 0.148413, this is the probability, student. So now you solve 0.0 then 0, 0.00. So how could you find? Again, go to the normal distribution table and search 0.00. 0. Now we are going to find phi 0.00. So how could you find? First of all, 0.0, 0.0, search 0.0 in the first column. So where is 0. This one 0.0, and then go to the 0 characteristics. This is 0, this is 1, this is 2, so 0 characteristics. So 0.0 and then 0, this will become 0.5000000. so this is the probability by help of Z standard normal distribution. So student, write in this way 0.8413 and this one 0.500, subtract this one, you can got probability. This is the method in which we are going to find probability by help of standard normal distribution table. Okay, now next one we have similar example, and similar example by help of another. For example, what is the probability whose income less than whose income, for example, student, next similar example where mean mu is equal to $1,000, standard deviation is $100. What is the probability that income between $790 to $1,000? So again, make a data mu equal to $1,000, for example, sigma is equal to $100. okay, so students, this is the data sigma when mu is equal to, we are going to find probability between $790 to $1,000. so 790, take for example, first of all we are going to convert x into the z part, x minus mu upon sigma, and 790 minus mu upon sigma, again 1000 minus mu upon sigma. Then this putting the values of mu and sigma, this middle part becomes a z, and putting the values of mu and sigma, we got minus 2.10 to plus 0.00. This is lower limit and this is upper limit. Now again, by help of property phi upper limit, we can write as phi, this is upper limit, and minus phi lower limit. Phi is the notation simply, or nothing more. Phi lower limit and phi upper limit. Okay, now see this one in the table, 0.0 then 0, already we got in the previous slide point. This will becomes, already see the solution, 0.5000 minus, now next one is student, minus 2.1 and then 0. So this value already we search in the table in the last, for example, numerical, but this value minus 2.1 and then 0. Now student, we are going to search this value in the normal standard normal distribution table. So where is the value, for example, in standard normal distribution table, minus 2.10. so in this way there is no any minus negative value, so this table belongs to the positive value. So go to the previous page, for example, student, this one, these are values belongs to the negative value. So we are going to find phi minus 2.10. so first of all, in first column go to the minus 2.1 and then go to the 0 value, for example. So minus 2.10 and then 0. So minus 2.1, go to the minus 2.1. Where is minus 2.1? This is minus 2.1, minus 2.1, and go to the 0 characteristics, 0. Where is 0 line? This is the 0 column, first one. So this will becomes 0.0179. So write the value 0.0179 instead of this probability function, and this is 0.0179 students. So 0.0179, 0.0179, and subtract this from this, you have got 0.4281. So for 4821. So this is what we call normal probability distribution. By help of this, now you can find probability similar numerical. If you are going to find only less than, so student, make into the z first of all x minus mu upon sigma. Just directly see this one. You are going to find probability x less than 790, for example. So first of all, x minus mu upon sigma less than 790 minus mu upon sigma, and first of all make z, and putting the value 790 minus 1000, mu is a 1000, and divide by 100 sigma, and solve this one. You have got z less than minus 2.10. so this is what we call phi. If only less than are there, not interval, then we can write as phi of minus 2.10 directly. Just the CDF property. If we are going to find less than probability, then take the CDF. This is what we call CDF. So take minus 2.10 from the table. This will give you the less than probability directly. So minus 2.10, we already find the probability, which is equal to 0.0179. So this is the probability. So this is a similar example. We are going to find the single interval, students. Now if we are going to find similar example, for example, more than, see this one, more than 790, students. So how could you find? First of all, convert greater than into the less than by taking 1 minus. Already we discussed in C, because in normal distribution table, in Z table can never provide you greater than probability. First of all, we convert into the less than by subtracting 1 minus, and then find probability x into the z, x minus mu upon sigma, and then convert into the z, and then write less than equal to into the phi minus 2.10. So this is the method in which we are going to find more than probability. First you try to convert into the less than, and they convert into the z, and this less than already we discussed in the previous slide. Directly we return into less than into the phi. Take the table value of that point, which is give the probability directly. So take the table value 0.0179, take 1 minus, take the difference from 1 minus, and you can got 0.9821. So this is another example in which we are going to find probability. So solve this one example, student. Now this is the working examples in which we are going to find another alternate method. Okay, this complete it yourself. Page number example number 6.7 of Walpole and Myers book, also 6.8 Walpole's and Myers book, and solve all these, for example, Walpole and Myers book exercise problems. So this is what we have, normal probability distribution. By help of this, we can use the standard normal table. We can convert, first we must convert into z, x into the z by help of x minus mu upon sigma, then use the normal standardized normal table from minus infinity to plus infinity, any values provide by help of this table. Okay, so this one, this is what we call this table, standard normal distribution table.